My name is AJ Lee, the Product Portfolio Manager for MGS, and Alex Vigorovich for our Applications Engineering team. With over 30 years of experience, we're going to dig into integration of projects, particularly in the life sciences industries. Now, MGS is a small business up in Minneapolis, Minnesota, right in the kind of tech hub, medical hub of the Midwest, with many of the largest pharmaceutical and biomed companies like Medtronic, Johnson & Johnson, and more in the area. And we've really leveraged that to build a staff and a team that's been around the life science packaging for some time now. We've proven ourselves to be experts in this niche business, and we really pride ourselves on finding unique solutions for the life science industry. While many of our customers will talk about OEE and staffing and productivity and run rates as key critical things to their operations, it's really in this life science space that we see that added regulatory burden where everything has to be really just right and be tracked and traced and really understood the whole way through. And we've really built our expertise on experience in that area. Within the life science space, we work with medical devices, whether that's diagnostic kitting systems to handling subcomponents like sutures and inhalers, all the way up to full production lines where we're taking products, using that assembly process and pushing all the way out to final shipping packaging. On the pharmaceutical side, we've also done product handling and secondary packaging for all levels of dose delivery, whether that's bottles or blisters or ampoules and syringes or sachets. Alex is going to talk a bit more. Would you want to take it away, Alex?
Thank you, AJ. What do we offer when we become your system integrator? We basically become a single supplier, and it simplifies your operation and reduces your risk. With our integration OEM management, we assign a professional project manager to oversee the integration process and make sure the schedules and budgets are kept. We provide OEM equipment purchasing. We manage all communication and coordination with every supplier. We provide OEMs with the specifications to meet your requirements. We organize and manage OEM design reviews, either live or online. And of course, we attend OEM FAT. After the equipment arrives to MGS site, we support all aspects of OEM equipment integration, including setup and layout, necessary electrical, mechanical, and controls interface, quality verification, system runs, and then we provide a complete line FAT where we simulate your factory conditions as best as we can to give you the best possible view of how well the line will run at your plant and how multiple machines and systems will work together seamlessly. When it comes to installation and service, through our global network of cohesive companies, we have experts in nearly every technology and industry to support your long-term success around the world. Let's take a look at this line again. I'll give you a brief overview of the process first. This line was built for a large manufacturer of medical devices. It received several components of a medical device, inspected them, assembled the components together, and processed the devices through several packaging operations. The line operated at the rates exceeding 150 parts per minute. First component arrived in trays loaded in the pallet. The trays were depalletized, and the components were unloaded from the trays. They were accumulated and passed through the components inspection system, where the functionality of the component was verified. They were also check weighed, and after that, the components were labeled, and the labels were printed with relevant variable codes, and the codes were inspected. The second element of the medical device was fed from bulk. The parts were singulated and oriented. They were labeled, and the label application quality was inspected. Two parts came together in the unique assembly module built by MGS. The assembled devices were transferred to a floor wrapping operation. A desiccant was placed into the package, and the parts were hermetically sealed. After the floor wrapping, the parts went to the leak detection system to inspect the seal integrity. After that, the sealed devices were moved into MGS cartoner. 2 literature inserts were added, and all components were loaded into cartons. The cartons were sealed and transitioned to a printing and inspection module. It was the start of the serialization process. Overall, the system integrated serialization and 3 levels of aggregation using a well-known serialization solution provider. The cartons were collected in groups and banded. The first level of aggregation occurred after that. The bundles were delivered to MGS case packer and they were aggregated into the cases. And after the case was sealed, the cases were transferred to the palletizing module. And that was the third level of aggregation when the cases were placed on the pallets. There are several elements of the system which exemplify MGS competency. One of our strengths is our ability to provide a number of product handling solutions. Bulk feeding is one of them. We tool centrifugal bowls. One of them was used to feed one of the components of the assembly, singulate and orient them. We also build vibratory balls and tracks for feeding a great variety of different parts. They're usually custom made for a part, or some of them could be tooled to run several different parts as well. We provide a variety of pick and place mechanisms. Rotary for high rate applications, rates exceeding 600 parts per minute. We used one of them to pick the literature in this system. Extended capacity magazines allow operators to perform other tasks while a massive number of inserts are being depleted. We use a number of escapement mechanisms to ensure reliable picking of the literature inserts. We also use intermediate pick and place mechanisms for slow applications. They're often used in the inspection systems. You can see the insert is being pulled, inspected, and the invalid inserts are being rejected. MGS has a long history of robotic integration. Robotic solutions offer high reliability, great flexibility, and significant savings. One of these robotic systems was used in this device assembly system. On the screen, you can see the placement of wrapped medical devices into the buckets of the cartoner. We used vision guidance to track randomly arriving pouches and also conveyor tracking for gentle and precise product placement. There are other examples of integrated robots and also MGS built gantries placing products in different applications. As you can see on the screen, we seamlessly integrate one or several robots to work in unison with the rest of the system. Again, conveyor tracking for precise product placement, point-to-point pick and place at high rates. And several robotic mechanisms working together. We have a number of different cartoning solutions. We used our Stealth CT, a continuous motion carton, as part of this line. The carton is capable of rates of up to 325 cartons per minute. You can see two types of literature inserts were placed, followed by product placement. The cartons were picked, pre-broken, and placed into the carton flights. The products and inserts were loaded into the erected cartons, and the cartons were closed and discharged from the machine, in this case, into the printing inspection module. This is another example of the Stealth CT cartoner. This video shows a few more details of its operation. In this case, this cartoner was used to place bottles into cartons at high rates. The bottles come online and spread to pitch by the timing screw. The cartons are picked from the magazine, pre-broken, and placed into the flights. The flights ensure the squareness of the cartons. The product loading is gentle. You can see the pre-breaking device on the screen right now. We use barrel cam loader to gently place the products into the directed cartons. Here it is on the screen. And in this case, the cartons for tuck closure, we use 3-station tuck tooling. And tooling is specific to each particular carton. And we're doing it to ensure that the first carton out is of high quality. On this machine, we separate the controls. The low voltage and high voltage controls are separated and located in different enclosures. Another example where we feed and place the vials. There are 2 vials going into 1 carton. And there is also a medical device that we bulk feed and then add to the package. Again, it's a continuous motion cartoner. There's rather unique literature placement mechanism. The literature was placed vertically into the buckets. And here you can see the star wheel placing medical devices, and devices, as I said, were bulk fed into the star wheel. The carton pre-break is our standard feature. As I mentioned earlier, the bundles of cartons were aggregated into the case. We offer small footprint pharmaceutical grade case pack that could fit easily into most pharmaceutical suites. As you can see in this video, the serialization code of every carton is scanned prior to the case loading, and that's where the aggregation happens. After the case is sealed, the label is printed with the aggregation code, and we create the parent-children relationship by doing so. By scanning the aggregation code in the case, you could see all the children, all the cartons that went into this case. And the final operation was our palletizing. Again, we used the robotic device that we integrated to palletize the cases, and that was the final level of the aggregation. The label was printed and placed on the pallet, and again, we maintained the parent-children relationship throughout the whole process. When we assemble and integrate lines, we assume the responsibility for its OEE, overall equipment effectiveness. There are different techniques we use, and I'd like to talk about some of them. They might seem like small details, but over the life cycle of the equipment, they can make a very significant difference. Our central control system, we could safely start and stop every piece of equipment from that central controls. It collected the production and maintenance data from every machine in the line. It organized it and communicated it to the plant historian system. HMIs in every machine looked the same. They had the same push buttons. They were the same size. They followed the same control scheme. It helped the operators to significantly shorten the learning period. We placed marquee monitors throughout the line. Each of them displayed the states of every machine, also could display the production data, so the supervisors could see what's happening on the line. They made it much easier for the operators to diagnose the issues or the problems and tend to them in a timely manner. There are some other time savings techniques that we use to increase OEE. One of them is our IllumiGuard system. When the problem occurs, we light up the guard where the problem is to point to the operator the precise location of the fault. We also use one-touch troubleshooting. There is a fault seen on the HMI, and then by push of a button, it takes the operator to the page where the fault is described and the troubleshooting techniques are described to allow the operators to fix the problem immediately. And of course, post-installation, we offer remote diagnostic, troubleshooting, and interactive help. It's important, especially now when we travel, the travel can be limited, and our staff is available whenever you need it.